Okay, hello everybody. I hope you can see me and hear me well. Welcome to the first webinar session of NKE instrumentation. So our idea of this webinar is to keep it as a flash webinar. So there will be no PowerPoints. We will try to keep it into a 15 minutes range of presentation. The only time you will see my screen, it will be when I will show you the interface of the Ysense. So there will be different webinar sessions, some focused on products, mainly the first ones, and the next flash webinar might be more oriented into specific and dedicated applications. So what I will do today is talk to you about our Ysense logger range. So first, I will introduce you the different type of Ysense that we have in the range, what they measure, what are the main specification, until what depths they can go. Then I will present you the general interface that is common to all the Ysense, and we'll go through some example on the screen of different type of applications and how you can use the different programming specificities of the Ysense in order to optimize your measurements. So first, I will go through the different parameters of the Ysense. So all the Ysense are mainly built on the same type of size. They're all of 40 millimeters diameters. And you have this, which is about 20 centimeters, that is common to all Ysense. This means that if you have any accessory, clamping, protection, it's generally compatible with all the Ysense range. Then what will change from a Ysense to the other would be this part, that will be the sensor part. So first, now what I'm holding is a Ysense TD, that could also be a Ysense wave. I will talk about this a little bit later. So TD stands for temperature and depth. So all our Ysense have at least temperature and depth, and then more sensors. So this one is just temperature and depth sensor. So you can see pressure sensor here that is behind a protection and specific coating to avoid any fouling to come in, and temperature sensor that is slightly extracted from the housing in order to optimize its response. So typically when we are making some profiles on when we are placing this Ysense of fishing net, we want to have the optimized response of the sensor. So you have 3 depths possible for this Ysense: 50 meters, 500 meters, and 1000 meters. Then we have the Ysense CTD. So as you can see, we remain on the same small and compact diameter, but then the top part is a little bit longer. So the depth sensor now is on the side, and on the front side, I have first a protective cage. So this cage has 2 purposes. The first one is to protect the sensor from any shock, and the second one is to prevent from biofouling. So it is a specific copper hollow cage that does not impact the measurements. Moreover, this cage is removable, which eases the maintenance of the instrument. So you can remove the cage and clean the cage with a metallic brush and clean with fresh water the cells. So I'm just showing you the cells. So here you can see, so you have 2 types of measuring cells, one measuring the conductivity and one measuring the temperature, and you have one on each side. So you have 2 versions of this Ysense CTD, one for 50 meters and one for 300 meters. And the Ysense CTD measure these 3 parameters and also calculates salinity as well as sound velocity. Then we have what we call the optical Ysense. So as for the Ysense CTD, you have the pressure sensor on the side, and in the front you will have an optical sensor. So we have Ysense TBD to measure turbidity together with pressure and temperature. or also now coming up the Ysense DO to measure dissolved oxygen. So you have two versions also for these sensors, one for 50 meters and one for 500 meters. And then we're going into the deep sea instruments. So we can measure whether temperature and pressure, or accurate temperature with the temperature sensor that is out of the common body to be able to measure accurate temperature, or this specific Ysense that is called Ysense AD, that stands for acceleration and depth, and that is dedicated to a specific application. It's to monitor the acceleration of free-falling elements, and more specifically piston cover. So these instruments are in titanium housing and depth rated to 6,000 meters. So Ysense stands for Wi-Fi. So what do they have in common is that you don't need any cable, you don't need any specific software to program the instrument. The only thing that you need is this small tool that we call the magnet clip. Actually, it's just something that you clip on the Ysense, and inside this, you have a magnet. What it does is, once I put this on the Ysense, I can activate the Wi-Fi of the Ysense, and then you can see it with your tablet, your smartphone, your computer. It appears as if it was, say, an internet box. Then you connect to this, and you can access the interface. So we'll just do this live with this Ysense CTD, and I will very briefly show you the interface. So here you can see that the Ysense CTD network appeared in my lease. I'm just connected to it. And then I will type again the IP address of the system, and I will arrive on the main page of the Ysense. So first, what you can do is quickly check that the instrument is functioning. This is called real-time measurement. This cannot be used in water. It's just to check that the sensor is properly functioning and the instrument is responding properly. On this tab, which is called measurement files, you can see all your measure files. So what you can see is its .csv file, which is standard, which eases the post-processing. And when you have different type of file, you can whether download all the files, or you can also click on this information point. This will give you the main information about the measurement. And you can also click on the small eye here, and you can even pre-visualize your files before downloading them. Here you have a tab which is about channel configuration. So this tab is mainly the information that is stored from our metrology laboratory. So all the calibration information of the sensor are stored here. And then we're finishing with the main tab. So here you have general information, software version, memory capacity. So their data is stored in flash memory in order to be the most resilient, even in the harshest condition. Here you have the memory and power capacity at present. Then you see here on the right-hand side, acquisition settings. This is the main tab to program the instrument. So you have this tab, and on the right bottom corner here, you can see a stop and start. Typically, you program your system and you click on start. You have three modes. One is called manual, one is called date, and one is called condition. Manual mode, it would be the operator with a smartphone or the computer, which will press start or stop. Date is a typical schedule with a calendar. And condition is condition start and stop based on any of the parameters of the instrument. For example, I want to record only at these depths. I want to stop recording when I am out of the water. I want to record when there is a saline entrance, etc. And you have two things. The first one is the monitoring period. It's how often do I want to check this condition in true. For example, I put 1 minute. So every minute I will check if my conductivity is over or under this value. And if this is true, I will measure for the speed stated, the sampling speed stated here in the measurement period that is also fully variable. So this interface and these three modes of start and stop modes offer a very high variety of way of deploying and using the Ysense. So now we'll go through some example of actual deployments and how the Ysense are used. So first is apologies, it's my own hand drawing. I'm not a painter. I just made it with our own capabilities here at NK. It's a bit like my haircut. I think it's the same for a lot of people. We are in a quarantine haircut time. So I put 6 examples of how you can use the Ysense, and I will show you sometimes how we can match them with the accessories, etc. So first, we have spot and profiles. So you want to make some point-to-point measurement. There are 2 ways that are optimized to make profiles. The first one would be the manual mode. I am on the field, I am with my tablet or smartphone. I type some info on the position or where I am, or whatever. I put start, deploy the instrument, recover the instrument, and stop. The second one would be a pressure-based measurement. Say, once I am in the water, I want to stop the measurement, and once I'm out of the water, I want to stop it. Typically, in that case, you would put a start condition a little bit below the stop condition. For example, I'm starting to measure when I am at 2 meters depth. I do my profile, I come back, and I stop the measurement when I'm at 1 meter depth. And the interesting thing on this is that the Ysense is keeping all the information of this schedule, so you can repeat the operation all the time until you manipulate. This means that you can even pre-program the Ysense before the deployment and leave the instrument to any operator. The only thing you have to tell to this person is put it in the water, wait, deploy, recover, and that's it. Then, going together with these condition start and stop, we can go a little bit further and put this instrument together on fishing nets. To do so, we have some specific dedicated protection. This one is for the Ysense CTD, for example. You will put this protection on the fishing net, and once the Ysense is inside the water, fixed on the trawler, on the sand, or whatever, it will start measuring. And once it is out of the water, it has the capability to download automatically the data to a computer. We also have a specific solution, which is called the Ysense Hub, and that has the possibility to show dedicated graphical interface on the vessel. This we might be talking about on a dedicated webinar. Then when we talk about continuous measurement, which are some of the one we most encounter into coastal water or rivers for long-term monitorings. For example, you could have, say, a continuous monitoring of water temperature and salinity at different depths. Typically here, a scheduled monitoring could be made, like I want you to measure once every hour during all this time. But also what can be done if you are looking at a specific event throughout the year, for example, a thermocline, you can say, I want you to check what is the temperature every hour, and if the temperature achieves or reaches a certain level, then measure much more quickly. So in that case, you are optimizing the battery and the power consumption. What often we can encounter, especially in rivers also, can be bottom frame, for example, for turbidity monitoring. So in that case, as it's an optical sensor, you can have a separated wiper with its own power that would be cleaning the optical lens of the Ysense. As for designing some moorings, if you have any type of mooring lines, you can use simply those clamps. These are operable with all the Ysense because they all have the same diameter. What we advise is to put the Ysense looking backwards and to place the clamp closest to the sensor part. We do not advise, and it's not necessary to have two clamps per Ysense. It's even better to just clamp a single one just close to the sensor nose down. If you are doing the profiles, you can see here on the bottom you have a small rope, and then you can just deploy the Ysense as it is because it's negatively buoyant. So you just fix it to whatever rope, deploy and recover. Then I will just talk to you about a specific measurement type, which is using the Ysense wave. So the Ysense wave exactly looks like a Ysense TD, the same size. But what it will do is it will use a specific measurement sequence. Here we have an application that is, we have some ongoing measurements for more than 1 year now in Brittany area, where there is a marine submergence risk. So marine submergence generally risks to operate where you have high tide and high waves or stormy conditions. So what the institution is willing to do is to validate some models, and to do so, they want to measure only when the data should be the most interesting for them and for the models. So actually, the Ysense will be placed on the rocks here and would be out of the water during low tide. And then it will start measuring at a depth condition, so only measuring on water. Then what you can see in red here is a specific sequence. So the Ysense wave has mode where you can measure the pressure data up to 16 Hertz, which allow you to take multiple points along the waves, and then afterwards in post-processing, be able to draw the wave. So on the one hand, with the condition start and stop, you optimize the battery capacity, and on the other hand, with the specific high speed and burst sequence, you're able to modelize the wave. So this Ysense wave is actually a very low and cost-effective alternative to the complex wave measurement solutions. Then finally, the two examples that you see on this side are mainly example of deep sea and specific measurements. For example, here it would be monitoring the movement of the mooring line during the deployment or measuring temperature in deep sea. And this one is the application using this Ysense AD. So this Ysense AD is very specific and dedicated to mainly a single application, which is the piston corer behavior. So what it does is it will be deployed waiting to reach a certain depth that would be close from the sediment area. And once it reaches its depth, it will record at very high speed, 100 Hertz, the acceleration of this piston corer. So this will give information of this key moment, which is the impact and the insertion of this piston corer. Okay, so that's it for this flash webinar. I hope you had a general view, first general view of this Ysense range and what it's capable to do. if you have any questions, please feel free to write, whether in this flow of conversation or write us an email afterwards. Also, if you have any comments on how these flash webinars are performed, this is the very beginning for us to make this flash webinar. We have very few time to prepare this one, and we'll have more time to prepare the following ones with the freeing of the quarantine. So any advice, we are very welcome. And first, once again, thank you very much for your presence and participation. Bye-bye.